Hey guys, in this episode we're going to do a crash course in deployments to AWS. There are many ways to deploy an app with varying levels of quality and cost. So to make this successful, we're going to start with something simple that won't lead you down any dead ends, but has room for improvement as you get more advanced. Let's take a look at this architecture. In the center will be our CATS API, running as a Docker container on a cluster of Fargate instances. These containers are managed by Amazon ECS, basically a better version of Kubernetes for AWS. Our apps will be talking to a MariaDB instance hosted on RDS. Finally, in order to route traffic to the containers, there's a load balancer in front. This part is important. Otherwise, anytime we scale in or out, deliberate or not, we need to update DNS. We'd also need to manually update TLS certificates, which is onerous at best. When we use an AWS load balancer, all this is taken care of for us. So let's get started. Okay, so in order to package our application, we're going to need two things. The first is to add the application plugin, and then we need the Gradle Shadow plugin. The application plugin is going to let us define a main class so that when you double click or execute the jar, it will run the main class rather than just treating the jar as a library. And then the shadow plugin is going to combine all of our dependencies into one Uber jar. So now that that's defined, we can configure our application and we can set the main class to dev Andrew O'Hara cats.main.kt. So that's the reference to our main class in main.kt over here. Now we can go and build our application. And if we look in the build libs directory, we see that we have two jars now. The cats.jar is just our code, but cats.all is going to have all of our dependencies. And if we were to execute the cats.all jar, we see DB URL is required. Makes sense because we never actually set the environment. But this means that we've executed our app and it's pretty much good to go at this point. So the next thing we're going to need to do is Dockerize our application. So let's go and build a Docker file. We need to choose an image to run with here. So if we go to Docker Hub and Temurin, so Temurin is the Eclipse distribution of the JVM. And they actually have a nice Docker file here, which gives us almost everything we want. So let's copy this and let's have a look at what it does. So first we're going to build with Eclipse Temurin version 21. That's the same version we're running our app with. And then we're going to take the JDK that comes with it and build a Java runtime. Now, looking ahead, we can see that it's only adding the Java base module, which isn't good enough. So we're going to need to add all module path, which is going to give us everything that we need to actually run our application. And so once it builds the JVM, it's running off of Debian Slim, which is pretty good, configuring the Java runtime, and then here's when we actually install our application. So japp.jar is what it's expecting to find on our local file system, which isn't what we're going to have. So we're instead going to point to build libs cats.all.jar, and we're going to change the jar that we're executing to that same one. So let's test this out. Let's Docker build this. And I think that worked. So let's now tag it. So cats latest. And so now we can do docker run cats latest, and DB URL is required. Cool, that's good. So we've Dockerized our application, and now we actually need to publish it. So since we're working with AWS, the easiest way to publish our app is to the Elastic Container Registry. So this is basically Docker Hub, but private for us. And we can create a repository for our app. We'll just give it the name cats. And we have the choice between using immutable or mutable tags. Meaning, if the tags were mutable, we can just keep on pushing latest. Otherwise, if they're immutable, we'll have to always be incrementing or changing the tag that we upload. So you can use the date, you can use a build number. I recommend you use immutable because it means you can't break previous versions that you've had, and makes it easier to deploy later versions of the app. So immutable, standard encryption is fine. Let's create that. So if we go inside here, it tells us how to push to our repository. And so we're going to need to use the AWS CLI to log in to Docker. So let's copy this command, and we can almost run it as is, but I am going to log into my personal profile over here. And we are logged in. Now we need to build, which we've already done, and we need to tag it. So we are tagging cats latest to this repository, but instead of latest, we're going to give it the version 1. So let's do that, and then we're going to push version 1, and it's pushing. Cool, done. Let's refresh, and we have version 1, 117 megabytes. Obviously, we can put a lot more effort into making this smaller for faster scaling. Most of the space is probably going to be for the Java runtime, which, even though we made our own custom runtime, we're still using all the modules. We're not doing any stripping whatsoever. But that's something you can do later. So for now, we have our image, and we are going to need to do some prep to actually deploy our application. The first is we need a database. So Amazon RDS, and we can create a database. Before we used MariaDB, so let's keep doing that. We want the latest version. Production is fine. We'll call this cats prod. Username is admin, and we want to keep the secrets in Secrets Manager. So this is nice because RDS can occasionally rotate the credentials, and our apps can go and get them automatically through Secrets Manager. We want burstable. Actually, let's switch to free tier for now. We're going to use burstable, which gives us the option between T3 and T4G. So T4G is a bit better bang for your buck because it's using Amazon's Graviton ARM CPUs. General purpose 3, 20 gigs is the minimum, that's fine. No multi-AZ. We don't need to set up any connections ahead of time. The default VPC is perfectly fine. Subnet group default 1 is fine. We don't want to grant public access. Otherwise, well, I mean, it's password protected, but it's still good practice to physically isolate all your resources. For the VPC, the default one is fine. Default security group is fine. All that means is that pretty much only things within the default security group can talk to the database, which is fine. Availability zone, we don't care. Certificate authority, don't care. Password authentication, standard insights, no enhanced monitoring. We do actually want to go into additional configuration over here because we are going to need to provide a name for our initial database. Otherwise, our app isn't going to be able to create its schema. Yeah, like it can create the schema, but it does need to have a database with the name cats. All this is fine. I don't care about backups. And estimated monthly costs. Oh, yeah, this is going to fall within the free tier. Okay, so that's fine. Let's create it. Oh, master password. Sorry, I need to switch back to Secrets Manager. And let's create it. Cool. So that's going to take a while. In the meantime, we can go and create a role for our task. And we're going to need this for a couple reasons. We need container service for a task. And we're going to need this to do three things. The first is that it's going to need access to secrets. Now, we could come up with a much more finer-grained policy than this, but that's good enough for now. We're also going to need to push to CloudWatch logs, so all of our logs can go to the logging storage. The final thing is we are going to need to pull from the repository. So container registry pull only. That's good enough. We give this a name. It's going to be cats prod, and everything else is fine. Cool. So now let's go over to ECS. We are going to need to create a cluster over here. Now we could try to go and fully optimize our costs by using EC2 instances with reservation and stuff, but Fargate is really easy to start with and it's pretty cheap regardless. Everything else is fine. Actually, call it prod cluster. Let's create that, and that is going to go in CloudFormation. Unfortunately, this failed. So create cluster, unable to assume the service linked role. It's really weird why this is required, but basically what this is saying is that we need to make a role for ECS to use. It's really weird. Let's just go and delete this stack, and we are going to need to go back to IAM and create a service linked role. This is thankfully pretty easy. So AWS service, container service, and we take the top one, Elastic Container Service. This one doesn't give us any options. It knows what it needs. And we'll call it ECS Service Role. Okay, now that that's created, we can dismiss this and we'll create a cluster again. Prod, Fargate, go. So we can monitor this in CloudFormation. Things are happening. In the meantime, let's see how our database, oh, it is available. That is perfect. Okay, let's have a look at it. And there are two things we need. The endpoint, and we need the secrets ARN. And so that is fine. Let's see how our cluster is doing. And it is done. Great. The next thing we can do is go back to ECS, go to task definitions. So before we actually create a service, we need to define what a task of this service is going to look like. So we'll create a new one. We'll call it cats prod. Fargate, that's fine. For CPU and memory, we can probably just go to the minimum. We don't actually need a role for the task itself, but we do need cats prod for the execution role. The difference is, for the task role, that's what your application is doing in the code. The execution role is for everything that ECS is doing to run the task for you. So getting secrets, logging, pulling images from ECR. So that's what we created our cats prod role for. So inside of our task, there's going to be one container. We can give it a name, and we need the image URI. So if we go back to the registry, ECR, we can copy that URI, and we need to choose the tag, which is just going to be 1, because that is what's there right now. Over here, it likes to default to port 80 for HTTP. which is normally fine, but we're running on 8000 by default. So we'll just use that. And we're going to need to choose a whole bunch of environment variables, the same environment variables that we used to run our app locally. Except we are going to need to create a new Google client ID. So this client ID over here is configured to work locally. It's going to localhost. So we are going to go to the Google Cloud Console. We go to clients. And let's create another one. This is going to be for web. We'll call it cats prod. And we need to think ahead for what domain we're going to be using. So I own andrewohara.com. So let's say that this is going to be cats.andrewohara.com. And for the redirect URI, it's going to be cats.andrewohara.com/UI/redirect. And this is the path that we defined earlier when we built the OAuth login flow for our app. So let's create that, copy the client ID, and let's start defining some environment variables. So for audience, it's going to be that. Next, we need a redirect URI, which is going to be the same one we defined in the console. Okay. Next, we need the DB credentials. So DB URL, we can just hard code that. If we go back over here, connectivity, we copy the endpoints and we can paste that there. However, for DB user, it's a bit different. We are not going to be hard coding a value. We are getting a value from Secrets Manager. So back over here to configuration, we can copy the ARN of the secret. We paste it, but we need to get more. So inside of the secret, there is a username and password. So we get username, and in order to get the latest version, we just do 2 empty colons afterward. Did I do that right? Username? Yes. So for DB pass, a value from here, get the password and latest. Okay, what else? Issuer, we can just copy that, that's fine. And JWKS URI, we can copy that, that's fine. Okay, that was it for the environment variables. Logging, we're gonna use CloudWatch, that's fine. That's why we add the permission to our task execution role. Everything else is fine. Default, yes. Let's create that. Hey there, Future Andrew here. So one thing I forgot to show you is that when you're creating or revising a task definition, one thing you need to be really careful of is to make sure that the operating system architecture matches the one that you built on, unless you're doing some cross-compiling. So since I'm on x64, I need to select an x64 task definition over here. Otherwise, if I was compiling on ARM, like on a Mac, or if I'm doing some cross-compiling because ARM is just more efficient on AWS, I would need to choose this. So just keep that in mind. Otherwise, you'll probably end up with instances where your task can't deploy or fails to deploy, stuff like that. Okay, so now that we have our task definition, and it's probably calling it number 4 because I had some previous versions of it kicking around. Now, let's go into our prod cluster, and we're going to create a service. A service is basically going to ensure that some number of our tasks are running. It's also handling load balancing, that sort of thing. So capacity provider, Fargate, that is fine. We need to choose the task definition and give it a name, cats prod. So we want 2 replicas to start with. 2 is usually a good number to have for prod. That's all fine, and the only thing we want to add is load balancing. So we don't have an existing load balancer here. So we'll create a new one, and we'll create a listener. So we could just use HTTP, maybe if we were just talking within our virtual private cloud or VPC. But let's go and do HTTPS, which is going to require a certificate. Now, I already have wildcard, which will work, but let's show you how to do this. Let's go to Let's go to ACM, Certificate Manager, and we are going to request a certificate. This one is going to be for cats.andrewohara.com, and we get to choose how we're going to validate that we actually own this domain. The easiest way is to just use DNS validation. It'll still work regardless. You just need to validate that you own this domain. So we are pending validation here, and we could either just export this stuff to our DNS, but since I am already managing it in Route 53, I'm just going to do it in one click. And we wait a little bit. And there we go. We now have the certificate for cats.andrewohara.com. So let's go back here. We're going to refresh and we can choose cats.andrewohara.com. And for the target group, this is essentially a list of places where your task is running, and the load balancer is going to choose between them where it's going to send the traffic. The only thing we might want to change here is change the deregistration delay from 5 minutes to 30 seconds. That's way too long. It's also going to be running health checks. And since we already have the Swagger UI running on the root path, that's going to function perfectly fine. Otherwise, we could make a health endpoint in our app. So let's go and, I need to give it a name for the load balancer. No, we'll just call it prod. Because a cool thing you can do is you can use host name matching to share the load balancer between every single service that you have. So let's do that. And this is going to get created in CloudFormation, and it's going to take a while. So hold, please. Okay, we've reached a milestone over here where the ECS service is now being created now that the load balancer and the target group are created. So if we go back over to ECS over here, we see that we have a service and there are 0 of 2 tasks running. So we can go in over here and have a look at the tasks, and we can see that it is working on creating 1 right now. And we can dig a little further into it, and if there are any logs, they would be right there. There aren't any yet because it's still provisioning. So we are just going to, running, great. Let's see if there's any logs. Ooh, what's all this? What is all that? Failed to, haha, yes. I messed up the database URL. Okay, so this is actually quite good. This is going to be really helpful to watch. So for task definitions over here, this is where we go and create a new revision where we can go and update the environment variables. So for DB URL, what I forgot is it needs to be JDBC, MySQL, port 3306, I'm not sure if that's required, but then /cats to connect to the cats database. So let's go and create that new revision. Then if we go over to the cluster, to the cats service, we are going to update the service to go from revision 4 to 5, which is the latest. Now let's go and update that. Okay, so a minute or two later, we now see that we have 1 running instance. And let's go and have a look at it and go over to the logs, and we see running on localhost 8000. Okay, that's pretty good. Now we've got the second one being provisioned over here. So in the meantime, let's go and have a look at our load balancing. So inside EC2, There's target groups, and if you remember, this is basically our lookup of duplicates of the task so that we can load balance between them. And inside targets over here, we have one, and the second one is coming up. If we go to the load balancers over here, we see that we have prod, and, oh, did I make a mistake? Why is it port 80? I made a mistake. I have HTTPS running on port 80. So let's go and fix that. Let's add a listener here. HTTPS port 443 forward to the cats target group. Choose a certificate, catsandrewhare.com, and add. Alright, then let's delete this because this doesn't make any sense anymore. Why can't I edit? Edit, delete, confirm. Yes, alright, okay. So even though it has a DNS name over here, if we were to just go to it, it wouldn't work because of the security group. So by default, security is using the default security group. And if you recall, the default security group only allows traffic from itself. So what we need to do is create a security group for public HTTPS. Allow public HTTPS. So inbound, we allow HTTPS from anywhere. We create that. And back at our load balancer, we are going to edit the security groups. We do need to keep defaults because remember, both the load balancer and our tasks are running on default, and default only allows itself to talk to itself. So this load balancer still needs to be on default so we can talk to the tasks, but we can add our public HTTPS. So now, if we were to, the name on the certificate is invalid. It's expecting cats.andrewohara.com. So we need to add DNS because we have a certificate over here that is expecting the host name to be cats.andrewohara.com, and if it doesn't match, then the request will fail. So let's go to Route 53, which is the DNS provider that I'm using, but this will still work for whatever DNS provider you have. So for andrewohara.com, we are going to create a record for cats, and AWS is pretty awesome here, where we can just select a reference to our load balancer rather than actually putting in the DNS name. It's much faster to do it like this for resolution, not just for yourself. So we choose prod, we create the records, and it might take some time to propagate. But if we go to cats.andrewohara.com, there we go. Our app is running. Let's test it out. There we go. Seems like we're talking to the database correctly. Let's log in. UI, sign in as me. There's all that. Go back. Authorize our request. Create a cat. And list once again. And there we go. Except our app is now running in prod on our own custom domain with TLS. And that's pretty cool, isn't it? All right. So one thing I forgot to show you was how do I update my app after I've already deployed it the first time? Well, let's say inside of our main function, we were to make a small cosmetic change, updating the Swagger UI. However, one problem I've run into in this demo during test runs is that the way the deployments works on ECS it's blue-green. we first make our replacement tasks and then shut down the old ones. But since we're running with a tiny little micro database instance, it's actually incapable of handling enough connections for 4 apps at the same time. But like, why the heck am I using 20 connections here? That's probably too much. So one thing I will try over here is inside my connection pool config, I'm going to set the maximum pool size to something more reasonable, like 2. You typically need very few connections, especially if you're doing tiny little tasks with a quarter CPU like this. So let's try that. Let's do a build. And then we need to create a new container. Docker build this, tag it with cat's latest. Okay. And then I need to look up the instructions on how to push to the repository again, because I always forget that. So I think I need this one where I'm retagging latest to be number 2. I already have a number 1. This will be Docker image number 2. That's done. Copy this, paste, change latest to 2. Okay, so let's have a look. There's number 1, and here is number 2. Now, next I need to go over to task definitions. I'm going to create a new revision, and all I need to update is the reference to the Docker image. So change 1 to 2, create that, and then we go to our service. So cats prod, update, go from 6 to 8. And the reason why it goes from 6 to 8 is because number 7 was a test run and I got rid of it, but clearly ECS didn't get the memo. So let's update that, and this will trigger a deployment where, like I said, it's going to perform a blue-green deployment. And now that our 8s are up and running, we're going to start deprovisioning the old ones. So if we were to go to our EC2 target group, we're going to see them start to get deregistered. So in our targets, we have 4 in total, and 1 is draining. So we've deregistered both the old containers from the target group. That's great. We are now working on shutting down the 2 6s. But if we were to go to cats.andrewohara.com, we're going to see if our cosmetic change worked. And it always takes a bit of time to perform the cold starts when you're running with such tiny little containers here. But we can see that we have our hyphen. Pretty cool. Now let's follow up over here, and it looks like the deployment is done. We only have the number 8s. The deployment is finished, and that is it. Took 2 minutes. And that was how to make a simple but maintainable deployment to AWS. This architecture is good for a small SaaS without experienced DevOps, but has some cash flow to spend on cloud infrastructure. If you're doing this for yourself, you can scale down to essentially 0 USD with a pure serverless architecture based on Lambda and DynamoDB. It does have its own challenges, and isn't as cost-effective for higher, more consistent traffic, but it's a great option for personal projects. Let me know if you'd like to see that in the future. Apart from that, the next video will focus on automating deployments with GitHub Actions and possibly some infrastructure as code with CloudFormation. And that's it. See you later.